So I want to share out my screen. Come over here. We're going to take a look at this. Let's get these things up. All right. Chat window in case you have any questions. All right. So going over to the current week here, I've got the Lab 24, this robots lab. So this is a lab, it's kind of a review lab, kind of a ability to wrap up a few things and kind of see how far you've come in the semester and just to understand some other concepts and have them manipulate objects inside of physical space or physical space on the computer. So this is a robot and rooms. So we're creating these rooms that are grid-based rooms, and they're going to have doors on the walls. So if it's got a door on the wall, you've got the check method that we've got in this universe, and you can check north, east, south, or west to see if there's a wall on that door, or there's a door on that wall, sorry. And then if there is, you can move through that door if there is a door. So you can move to the next room over here if there is a door on that wall, and that door would indicate there is a possibility to move through. We're never going to have a door on a wall that goes into infinity or into the black hole or into negative space, that kind of thing. So if there is a door, you can move through it. That's the rules of this universe that the robot lives in. This is a very basic kind of programming setup. I've seen a lot of this done. I learned how to code using a similar method in a language called Pascal, and we worked with a similar robot setup where this robot was named Carol the robot, and so that's the history of this kind of robot lab. So what we're going to do is we're going to go ahead and download these 3 files. I've already done that, so I'll go ahead and just load those. I'm going to load up robot into my JGrasp. Let's go ahead and take a look at that here. Close out some of these other things. Too many things going on here. I don't quite need all of these open. So I've got this robot.java. I'm going to go to that, and then I'm going to load example.java, and where's the other one? Doorroom.java? Yes, doorroom.java. Okay. So if I look at this, this is the door room method. It's got a lot of different things. It's going to have east, west, north, south colors of the doors, and then it's going to print the colors of the doors out, that type of thing. I'm going to compile that. That compiles fine. I'm going to go over to the robot, and this robot has XY coordinates here. It's got a robot has a room and X and a Y coordinate here. So it's kind of giving you the location in space of the robot, X or Y, and then it's going to have the room that you are in. So you've got attributes of the room that you're going to pass over to there. So let's go ahead and compile that as well. So now we've got this robot and the door room classes that we've compiled. Come into here and we look at this example. What is this example doing? It's creating a robot. So remember, as we're going through this final PA and kind of doing this whole business of classes, the way you create a class is to use the class name and then create an instance of the class or an object that you're going to work with. So we're going to create a robot called robot. This is the declaration only. The next piece here where you have the new is actually creating the new object in space or in memory. So we've got this robot named robot that we're going to create and it's going to be at 3-3. So we're going to create a 3-3 robot here. The robot is at space 3-3, or is in a space called 3-3. So the way that this works is when we pass into the constructor over here, a 3-3, what are we going to be passing in here? This is the robot constructors. We've got one that passes a room and an X and a Y. Another one is a room. Then over here we've got a robot where we're giving the strings, and then we've got a int and an int here. So these are the two ints. This is what's going to happen. This is the constructor we're going to wind up using. You notice this has several different constructors. We've got several different ways we can construct this robot. We can create a robot with a grid and an X and Y, a grid only, and we can put the robot at 0-0, and then, or at the top left corner of the room here, we can create a grid and then pass an X and Y and put the robot in that, so we could center the robot inside of a grid. Then we've also got the ability over here to create just a grid, and it's going to put him in the top left corner of the given room. And then we've got this one that we got here, which is creates a robot at the given location in a width by height room. So width by height room in this position here of that room. So if we've got a 3-by-3 room and a 1-1 is the location, he'd be up here in a 3-by-3. So that's what we're going to do. Over here, this is a 3-by-3, creates a robot in the top left corner, a 3-by-3. And so that's what we're doing right here, is we're using this constructor here, the width height constructor, and we're creating a new door room of width and height 3-3. So that's what we're using here. That's what this example is creating with this statement right here in line 15. So then we're going to have the robot move east. Then we're going to say if the robot check north, then move north. Then we're going to have and see if he can move north. If the robot, then the robot is going to move west, and then the robot is going to say 2 rooms, and then it's going to move west. So this is what's going to happen. Let's go ahead and compile this, and then let's run this. We're going to see this, and we're going to see that happen there where the robot moves around, and then it goes over there, and it says 2 rooms here. And then it's going to crash here because it's going to say the robot hit the wall because we tried to move west when we could not move west. So that's the example of what's going on here. So let's fix this piece by going over here and saying if robot.check west, then robot move west. So we're only going to move west if we can move west. Else we're going to do robot.say can't move west. All right, so let's save that, and this will kind of fix this up a little bit. So let's go ahead and do this. Close out that. Leave that hanging around. Okay, let's go ahead and run this now. Run the example now. So we've compiled this again. And we're going to run this, create our robot. He's going to move over. He says 2 rooms. I'm going to do that. And then we're going to go look at west, and we can't move west, so we're going to stop. So that's what's going on here. The robot started here. He moved east, which was no problem. Then he checked if he could move north, and the robot could not move north, so we didn't do anything. Moved west. We said 2 rooms, and then we're going to stop. And then the robot checked if he could move west, and then he could not, so it said can't move west. So that's what we were doing here with the robot. Again, starting at 0-0 over here in the top left corner, and in a room of 3-by-3. So in order to do these activities here, I'm going to just run through quickly activity 1, a simple square. Suppose the robot is dropped into a square grid of rooms and starts at the northwest corner of the grid. So we're going to go northwest is north and west is up here in that top left corner again. So maybe you're, yeah, I'm probably in the wrong space on my screen here. So let's flip that. So yeah, so top left corner here in the robot. He's going to start up there in that 3x3 grid. Then he's going to move or come around here to figure out what grid size we have here. So this is the algorithm that we're going to do. It's a deterministic set of steps. Doesn't require outside information. So remember, he doesn't know how many squares there are in advance, even though we've programmed it to tell the program there's 3x3. The robot doesn't know this. So in order for him to say or tell us how many squares there are in here, we're going to have to calculate that. So if you refer to the size of the grid in your instructions to the robot, it won't work. So can't refer to that 3x3. So in a 3x3, how many times will the robot have to move through a door to run the algorithm? So if we've got a 3x3, it's going to have to go move, and then it can't move anymore. And so it's going to need to know how many spaces we've got over there in a 3x3. So let's go ahead and do that. Let's go ahead and grab activity 1. We've got a 5x5 grid here. And we're going to say int count equals 0. So we're going to set up a counter here in Java, and then we're going to go ahead and count the number of squares. Since we started at 0, 0, we're going to move all the way to the east as far as possible, since we're farthest west. And then we're going to move east until we can't do that anymore. All right. All right. So we're going to say if robot.check sub east. Just going to grab that so I don't have to type it. East. We want to begin here, and we want to go count plus plus. Then we're also going to want to go move, robot.move east. Else can go east equals false. All right. So that's going to be it for our algorithm there. And then we're going to want to go robot.say there are all right. And we'll just say how many rooms wide this is for now, and that will be it to see what we've got. Let's go ahead and run this. We're starting a 5x5. We're going to keep moving until we can't. And then there are 4 rooms wide, so we need to add one more to that to get our 5th one, because we know that we started at 0. So, or we could start this at 1 instead, so we know that we're starting at 1, and then we keep adding things. And then we can say for the room count, there are count times count rooms. All right, let's see if this is going to work. So there are 25 rooms. So because we know this is a square, we can do that calculation because we know we've got the same number up and down. So our height and our width are the same. So if we wanted to make this more generic, we could do some other things where we moved all the way to the east then all the way to the south, and we could count, and it would work for a rectangle. So that is the next simple rectangle is the next one. Then we can have any rectangle, then any kind of grid where we've got these weird shapes that kind of wrap up and down so that you've got pockets and other parts of rooms. So how many rooms do we have total in our space starts to get really different. So if you want to play around, you can play around with this. It's kind of fun to actually see something represented on the screen that you're using. So just wanted to kind of give you that, and also kind of go over this idea of multiple constructors here. So this idea that this robot here has several different constructors where we can set up different scenarios and set up different grids with the other pieces here for an XY coordinate system as well. So that's that piece that I wanted to go over. I think that's going to be it for as far as the class coverage piece. The rest of class, I think I'm going to devote to just